Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's my pleasure to introduce Zheng, who's been our research intern this summer. He's been working on the Lab of Things and how programming for the Lab of Things can be made easy using TouchDevelop. Zheng.
Thanks, Archman. My name is Zheng. I'm a third-year PhD student from Indiana University, and at IU, I work for the ethical technology in the Homes of Senior group, where we develop and test assisted living technologies that protect security and privacy for the senior citizens. And I'm very excited to work with Archman and the entire Lab of Things team this summer on the integration of Lab of Things to TouchDevelop. Let's see. Nowadays, a large number of sensors have been installed inside and outside the houses. For example, we have door sensors, window sensors, the sensors for temperature, humidity, motion, and distance. And in addition, we might want to control some of the electronic devices, such as our printers and TVs, in which we might not have any sensors installed on these kind of devices. Two typical questions people might ask would be, how can we enable the devices and sensors to be effectively interconnected? And for the academic research that needs a study to be deployed in a large number of houses, is there an effective way to achieve that? Lab of Things offers a powerful framework to deploy the field studies across different houses and enable easy data collection from the houses and into the cloud storage. In addition, the framework offers the user the capability of remote monitoring the system's running status and also even remote updating the applications that have been installed on these hubs. A fundamental component of the Lab of Things is the Home OS platform. The software platform is running on a local machine in each house. It's usually a smart laptop computer and known as the Home OS hubs, which connects and interacts with different types of sensors and devices. The Lab of Things is currently focusing on the home environments. However, the framework can be actually deployed to many other environments, for example, the nursing houses, office buildings, and even in cars, right? And there's nothing stopping us from deploying these technologies in these environments. Now let's take a closer look at the different layers of the local home OS we mentioned in the previous slide. In the existing model, the Home OS platform consists of 4 layers. Let's start with the very bottom one. The device discovery is taken care of by a few small programs named the Scouts. If the devices needs to be paired or communicated with the platform, then the Home OS drivers will also take care of that as well. Basic functionalities of the devices, for example, taking pictures for the cameras or monitoring the door opening events for the door sensors are written in the Home OS drivers. And also the management and access control functionalities are part of the Lab of Things functionality, the platform itself. And on the very top layer, we do have the applications. We have a few applications that actually allow the user to interact with different components within the platform. And my contribution this summer in this internship is to build a new layer on top of the application layer, which is called the lightweight application layer, and to allow the simple applications to be written by only a few lines of code, and allow people to write their programs on Lab of Things more easy. And I have to also mention that I also worked on some work on the device connectivity and device functionality layer, which enables the Connect sensor to be connected to the Lab of Things platform. And I will soon have a demo that showcases the integration of the 3 great technologies: Lab of Things, TouchDevelop, and the Connect sensor. Okay, some more details about the Connect sensor drivers on the Lab of Things. With a large set of capabilities on the Connect sensor, I define the following functionalities and operations for the driver. Any application on the Lab of Things platform can ask for the latest image taken by the Connect sensor, or it can subscribe to that event to receive all future color images that are taken by the sensor. It can also get the depth information, and for depth information, we enable both the depth matrix and the depth images to be returned by the Connect sensors driver on the Lab of Things platform. The Lab of Things driver also enables audio recording, so you can actually indicate a duration of the audio recording, and it will record for you and store the file locally on the hub. And at last, it returns the detected skeleton information and stored it locally so that any application can just fetch the file and for further analysis. Okay, so the Lab of Things is a very powerful framework and can support a large number of applications, and many of them are very innovative, to be created based on the local platform, different devices and devices and sensors, and also the cloud components itself. The traditional Lab of Things application follow a browser server model. So in order to write an application on the Lab of Things, you really have to follow the WCF service approach. Right? So you first have to start Visual Studio and create a project, and you have to define a number of endpoints and the functionalities within, here I have iService.cs. You have to expose a number of endpoints. And then another very important file for creating the Lab of Things app would be the service.cs file, where you actually implement these functionalities and the endpoints you have already indicated. And the developers might also want to write some code to respond to some standard Lab of Things events. For example, what actions to take when a new device is registered with the platform. Right? This is something that the developer needs to write about. And we can imagine that an entry-level developer to take a week or so to get themselves familiar with the entire framework and write some code on C# and also JavaScript, maybe index.html, and all of these things. They might have to write maybe 100 lines of code to implement the basic functionalities. However, we have to realize that it's very hard to write the .NET application on Lab of Things for a reason, right? Because they're very powerful. We can create actually a project to do image processing. We can do motion detection, a lot of cool functionalities. However, we have to also realize that there are also some of the user population that is also from the field of nursing, for example, and health informatics. And these users are not necessarily hardcore developers. They might not know about C# or Visual Studio at all. But we would like to allow them to create certain applications that are only involving very simple logic. So for example, let's imagine that a user has the Lab of Things system deployed in their houses. And then he wants to write a program to just visualize the data he collected from the sensor. And this is a very simple logic, and we don't need the user to write the whole .cs files and HTML files and the JS files to implement that. And we should allow the writing the code to be simple. And let's review the requirements again and see if we can somehow reduce the number of requirements, but still achieve the optimal performance and the functionalities that we can get from the Lab of Things platform. The first question would be, can we actually eliminate the requirements for C# and Visual Studio? It's actually okay. as long as we can make writing the program as easy as doing a few function calls and combine the function calls. In this case, these end users can simply just create some end user side, the client side scripts, right? For example, JavaScript, and just do the function calls and get the results. And if we are able to achieve this goal, then we don't need to require Visual Studio installation and the use of C# in this case. And also, I have to mention that this is a scenario that is specific to a particular circumstances, right? So we only think that this would work if you are only interested in some very simple logic, not something that we would do, for example, the image processing or the audio processing and motion detection. And we would like to offer the great programming experience to the Lab of Things users, but we would also want to eliminate the changes to be made to our existing framework and also the local platform. So one of the solutions would be to build a very special application on top of the application layer, and it's called the generic application. Okay, we call this a generic app because it's not designed just for one or two specific devices. Instead, it can potentially talk to everything, every sensor and every device that is connected to the Lab of Things platform. The generic app is running on the Lab of Things platform as a WCF web service. And now the problem becomes, how would an end user interact with the generic application? We can imagine two ways that the communication would take place. The first one is through the generic app's homepage. Like other applications on the Lab of Things platform, our generic app also has a user-friendly web interface. So if you go to the web page, it actually shows you that the developers have to fill out A and B in this logic. So if A, which is an event, happens, then we execute an operation, which is B. And in this screenshot, the developer actually choose if the door sensor is triggered, then it will ask the connect sensor to record the audio for an arbitrary length. And that's what this page tells you. And as you can see from this screenshot, the logic actually that is embedded in this web page is kind of fixed. To add the flexibility and also better user experience to this to this generic app, we have to consider other ways of talking to the WCF service. And one of the other options is to talk to the generic web service directly through RESTful function calls. And of course, the developers could choose to use some third-party applications to help the developer make the call. But both of the methods are okay. And what is my point here is the generic app really opens up the world of easily creating the Lab of Things applications. And to add flexibility and better experience, we really need to consider something else. Something with a better user experience and good functionality. And TouchDevelop is something that we have considered that to be a very good tool to interact with our Lab of Things generic app. The TouchDevelop is a technology designed and implemented by Microsoft Research. It's an app creation environments for mobile, cloud-connected, and touch devices. Anyone can visit TouchDevelop.com and work on their own scripts. With the help of TouchDevelop APIs, the developers who wants to write a good program can just reduce their lines of code that they will need to write. And we choose TouchDevelop to connect to our generic API for the following reasons. First of all, the TouchDevelop has a very user-friendly interface. So you just go to TouchDevelop.com and you make a few function calls to our generic app. And also, TouchDevelop.com would offer you the environments for code debugging. It can show you the variables and also the stack status, which is very cool. And in addition, the rich set of APIs is actually the second reason that we choose TouchDevelop. TouchDevelop has a standard API for displaying images and also the audio. So the developers do not need to worry about how do I actually implement that. And the third one is mobility. Just imagine that people have lab of things deployed in their houses, but they might be away from their home hub. With TouchDevelop, they might also be able to write simple programs with lab of things and have it deployed on the hub. And the next one would be to support standard HTTP and JSON. TouchDevelop has a standard library to make the post calls to our generic app, and also it can create and pass the JSON object, which allows the user to talk directly to the generic APIs. And the last one, support the export programs. Well, this functionality is pretty cool because I can actually create a lab of things application and export it as a library. So anybody else who is also interested in using the lab of things can also just use my library and make simple programs. Okay, for each function call that the generic web service provides, there should be at least one function on the TouchDevelop side to wrap the input parameters from the end user. So for example, send emails is one functionality that is provided by the generic web service. And of course, there is something on the TouchDevelop side that is doing sending emails. It accepts the user inputs and make the right function call. And, but on top of that, we might want some other processes to be standardized. For example, instead of just sending a text emails, we might want an image taken by the camera to be attached, right? And sending that emails. And on the TouchDevelop side, we have made send emails with picture available as well. So including sending email with picture and sending emails as two functions inside the library, where we are enable the users, the developers, to actually choose which one they want. And now let's consider an elderly care scenario to which the lab of things technology can apply. One of the challenges that the senior citizens to live alone would be the severe risk of wandering that come with the onset of dementia and other cognitive disabilities. And elderly actually suffering from these problems may leave their house without proper clothing or at an unusual time and just go wandering. The second risk is the social exploitation. Now, the elders are known to be, a vulnerable population, and as such are often targeted in various scams. So we do have an existing .NET application on the Lab of Things platform that can address this problem, which is the Alerts app. And in the Alerts app, it actually makes use of the Z-Wave door sensor and web camera. And the logic of the Alerts app is whenever the door opens, it can take a picture and then sends that picture as well as the alerts text through email, at this case to the caregiver, and then upload the picture and also the alerts text to Windows Azure, to the cloud. And now the question is, can we actually do the same thing with TouchDevelop and using the Lab of Things library? Yes, we can. And I'm going to show you how to do that. Can we switch to the demo machine, please? Okay. Okay. So what we do is we first want to go to touchdevelop.com. And after signing, I can find the Lab of Things. Oh, thank you. I can find the Lab of Things library, right? And I would like to make sure that the Lab of Things library is referenced here. And here my application is called Lab of Things Demo. And before I write anything, I would like to make sure that my URL, this is the URL to my Lab of Things hub, okay? And this URL is included, and also I have put in my email address here so that I don't have to type it when I'm receiving the alerts from the Alerts app. And then here I have a few names defined here, which are the Connect's name, the camera's name, the Azure name, and things like that, the key and the directory. The first task would be to initialize the connection. And I will use the hops URL and just call the initialization function from the LOT library. And then I want to make sure that the wall is actually displaying the objects in the right order. Let's first try something quickly and see if the LabelThings platform is running correctly. And I want to make sure that I can show all the devices that are currently connected to this platform. So it's just one line of code. LabelThings and then list all devices on the hub. And there you go. I should be able to run this. There you go. So here, with only one line of code, I'm listing all the devices and the sensors that are currently connected to this machine, serving as a Home OS hub. I'll go through them one by one. The first one is the camera that is actually part of the laptop, and My Connect is the name of this Connect, and also a bunch of Z-Wave sensors, and most importantly, we have the door sensor, which is right here, and is connected through the Z-Wave dongle to this platform. So it's working. Let's go ahead and create the alerts app. Remember, the first thing that we need to do is we want to subscribe to the events. Okay, we want to have the door opening events delivered to our scripts, right? So the first thing I need to do is to make sure that LabelThings subscribe to event is working. Sorry. Oh, not data stream. Subscribe. Watch events, okay? So here for watch event, I'm actually subscribing to those particular events, and this particular function needs to have the device name, which I already have it here entered. It's the door sensor's name. Nope. So it should be X. Okay, very good. Should be X. And the next one is the device type. This is a sensor, so I will just put sensor here. Okay. And the third one is an event name. And in this case, it's just get. I'm getting the status. So, okay, this function call is completed. To see any response from this sensor, we need to also create something like this, LabelThings. And we need to get the new events, right? So in this case, we want to do get new events. Okay, let's give it a name. Sorry, this is the name of the. So this is the device name. Device name is X. I'll put it here, and. Okay, so this particular function returns two output parameters. One is hasNew. It indicates if a new event is detected. And the second one is event, which is the actual events that is received. Okay, how about we ask the program to sleep for 5 seconds, and then time sleep. Okay, sleep for 5 seconds, and then we can make sure that if a new event is received, then we print out the events. How's that? Let's see, hasNew is true. Then we just put the event. Event is a structure in this case. And we want to make sure that event device name is actually printed to the wall, okay? And to make sure that it doesn't interfere with each other, I just want to make sure that, okay, let's do that. And let's ask the platform to sleep for 10 seconds in this case. Sleep, 10 seconds. All right. And I think that's it. Let's see. If I'm triggering this thing, it should get an event. There we go. It actually prints out the sensor that has been triggered, right? And since this is actually a structure, the event is actually a structure, I can also put other members. For example, the time is triggered and the location of the sensor in this loop. Okay, so the next step would be to make sure that we can trigger the camera to take a picture, right? And maybe we can post that picture to the wall. And the next step, I can do it this way. Let's see, get image. Okay, it's just one line of code. Okay, and at this time, I need the device name of the camera. So since I have already put it here, I can just say camera name. All right, and it's actually returned two variables. Two parameters. One is picture and one is picture stream. Picture is actually in picture objects within the TouchDevelop, and picture stream is a base 64 encoded picture stream, which can be used for WCF web service. It can be actually posted back to our Lab of Things platform. Okay, so we want to make sure that the pictures can be posted to wall. Post to wall, and in this case, you should be able to see an image. Okay, let me trigger that. Again. There we go. It's myself. Okay, so that's just one line of code, right? And how about sending the picture to the caregiver through email? It's also one line of code, all right? How about doing that? Email, send emails with picture. This is an example that I gave a few minutes ago. For this function to work, you have to put the subject here. The subjects, let's make a fake subject saying that TouchDevelop test. Okay. And the next parameter is the message itself, saying this is a test. Okay. And put a period here. And the third one is the email address. I already have my email address here, so I would just say email and just use the variable. And the fourth one is the image that I would like to attach. So in this case, it's going to be the picture stream. All right. So I think that's it. I will just run this. And once it's triggered, I believe it will take a picture, and it will also send an email to my email account. But it may take a while, so I will just show you when it arrives. All right, so this is the alerts app, right? When the door opens, it will take a picture and then sends the picture to the email and also potentially the Windows Azure Cloud. And as I mentioned, in the slides and a few slides ago, I also worked on some interconnectivity stuff, which actually enables the connectivity of the Kinect sensor with the Lab of Things platform. So can we actually replace the web sensor, the web camera with the Kinect sensor and provide a rich set of information? This is actually my next demo, but I would just make changes to the existing one to save some time and just show you how, oh, there you go. our alerts that received. I'll just first show you that. So this is the alerts that I've sent from our test scripts, okay, through TouchDevelop. All right, so let's do something to the existing alerts app and make use of this guy, the Connect sensor, and get the color information, the depth information, and also record an audio. How do we do that? It's actually pretty simple. Since we already have the logic built here, we will just replace the get image here with get color image connect, right? And I have also put the connect's name here, so I would just use the variable connect name, and it returns the picture and picture stream. In addition to the color image, I would also be interested in seeing some depth information. And in this case, I would say label things and then get depth connect. All right, and I still need to put my connect name here. Okay, and it's also returned as 2 strings. In this case, let's call it picture depth. And this one is, okay, that's okay, picture stream 2. And I want to make sure that both the picture depth and picture depth 2 is posted to wall. Let's see, this is posted to wall, right? Let's see, when it's triggered. Takes a while. There we go. It takes the color picture and also returns the depth information. And this is actually the depth image that is taken by the Kinect. And you can also get the depth matrix if they choose to do that and use the right API on the Label Things library. And how about we add the third functionality to the app, which is recording, like record the audio for maybe 10 seconds, okay? Let's do that within 1 line of code. Label things, and then how about audio? Okay, we have a record audio connect. Okay, as the first parameter, I need to put in connect name, and the second is indicating the duration. So in this case, 10 seconds. And we can actually run it again, and it will. Sorry. We can just do that. Oh, another alerts. So I need to trigger that. Okay. And it will take 2 pictures and, oh, sorry, I need to find this file. So it will actually do the audio recording for 10 seconds and then save the file locally on the hub. So I will need to find this file. Right here, I will just put, okay, so, okay, I need to find this file, so, okay, so this is the audio recording part, right? So, and it's working, let me mute that. And the next one would be to send the emails, and you've already seen that the sending emails is working. And how about we also get some skeleton information that is extracted from the images that are taken. And in this case, we can do label things and then skeleton information. Oh, sorry, skeleton. Oh, sorry, I should delete that. Skeleton. There we go. Get skeleton connect. At this time, I only need to put skeleton, the connect name here. And I want to store the results in a local variable, which is stream skeleton. And then I'll post it to wall. Post to wall. And let's run it again. When it's triggered, we'll take, okay, it's again taking the color image and the depth image. It will start the audio recording, and there you go, the skeleton information. It's actually recorded in a local file, and any application on the level of things who are interested in this kind of information can go ahead and grab the file and pass it and do some interesting stuff with that. So any questions about the two demos? All right. Can we switch back to the presentation? All right. And as our next steps, we would like to test the usability of the level of things TouchDevelop library. After we deploy the level of things platform in people's houses, it would be interesting to see how end users would actually interact with the touch-enabled programming environments. What type of level of things application they want to write, and for how long can they create that kind of application. Privacy is another issue. Besides researchers who deploy the experiments in people's houses, we also expect the level of things users who maybe know about TouchDevelop and want to use that to write simple programs, but we also want to know how do we isolate the resources that is allocated to each of the TouchDevelop scripts. Like, how do we prevent users to use each other's devices, apps, and local storage? How do we prevent that? And this is still the research questions we will need to answer in the next step. And at last, the speech-based programming. We do realize that at UC Davis, Professor Zheng Su has implemented that synthesizer to capture the keywords of the end user speech and automatically match the closest commands on TouchDevelop. It will be an exciting venue of research if we can expand this kind of work onto the level of things library, so that the level of things user can just briefly describe the task to be completed, and then the synthesizer would capture that keywords and match the corresponding level of things events for them. And at last, I would like to thank the entire level of things group and also TouchDevelop group for your help and guidance. And I have to say it's really fun to be here this summer as a summer intern. And thanks very much for your time to come here. And I'd like to take any questions you may have.
Questions? Come on.
So you did everything on your laptop, but I guess ideally I would have my smartphone or tablet,
Right.
Do some scripting, and then okay, we don't look at a set of houses, but it's just one house. What's the idea? I need some computer somewhere, or
you will need the level of things to run in your home environments, right? This is the hub that is running on your inside your house, and at the same time you can actually work on your scripts from anywhere. You can just access that because for each hub we have enabled the remote access, I believe.
So what is the cheapest hub I could put into my house?
I might not be the right person.
Laptop, which is a very low end, $150, $160 or an old PC. All you need is a Windows 8 machine running with the lab of things, Home OS software on it,
And Win 7.
or Win 7 also. And then connect devices. So the devices right now are Z-Wave and is connecting on.
Is there a plan to get that down? I mean, it wasn't exactly the project of the internship, but I wonder if you totally separate the user interface from how this thing runs, then I don't really want to manage another Windows 7 PC.
But you need a PC running presumably all the time in the home so that all the scenarios can work. So if you have a PC, simply.
So PC is the server to control everything?
PC is the place where all interconnectivity happens with the devices deployed in your home. Ideally, it should be on all the time. So any PC would do that.
Then you have to install updates and all of that.
Well, yes, but the lab of things gives you an interface for those updates from the cloud. And
If you're asking if you like whether or not you can run headlessly, Yeah, we have
Yeah.
like remote update capability that if you don't ever want to touch them.
Yeah, I was thinking of a little stick, costs $100. There's no user interaction whatsoever, it just works.
Or
Yes,
VM.
maybe in the future we will
Yeah.
VM has issues. I think Microsoft's hypervisor does not do USB redirection. So if you have USB devices, you run into issues there with the VM. But I think the answer is, the precise answer to your question is what Arjun was saying, like any PC that runs Windows 7 or 8 will do. The cheapest you can probably find is $150, $200. The reason it needs to be always on is because it's getting events from the devices. So if it's off and your door opens, you would know that it opened, and so that's the utility goes down if it's not always on. But with respect to Windows Update and stuff, if you don't want security updates, you can always switch them off.
Yeah.
In fact, we
Actually, yeah, I'm Sal Lark. I'm from the embedded team,
Right.
but Windows Embedded. So one of the products we have, the Windows Embedded Standard 7, it's a componentized OS. So it lets you, for these type of scenarios, you pick and choose the components or modules that you want for the OS. So if you don't want Notepad, so you don't get updates for servicing Notepad, things like that, you can exclude that from your OS image. And one of the things we are, that is one of the products we have right now, and we are thinking about future products, right? Having similar capabilities for these type of scenarios, Home OS, a lot of things.
What was that product called?
Windows Embedded Standard.
Oh, standard.
Yeah.
Can you pick which version of .NET Framework you run on that?
Yes. Yeah.
Okay.
Yeah.
So we need 4.5, by the way. So
Yeah.
7 or 8 doesn't really matter. Windows 10. We need 4.5.
What's the minimum SKU you run that on?
Yeah, what's the smallest footprint?
The smallest footprint, I would have to go. I'm on the PM side, so I can't remember exactly, but it's in megabytes,
Another
right?
video.
Hundreds of megabytes, not the gigabytes.
Okay.
So
That's cool.
I have another question. So your script had a start button, so you were basically starting your script and then checking if there was an event.
Right.
Now, for the scenario you described, this wouldn't work. You would want this thing to run when the
Constantly.
event happens. So
Yeah.
how would you make that happen?
We could just leave the thing running. I mean, currently, we can actually make some function call and, because the rules app, which is the generic app, is actually running on the server or the hub. So we can just leave something on the hub to run for a while and let the hub take care of, the functionalities. And we can just make the script to start the functionality and let the hub take care of the rest so that you can actually close that.
Do you have a plan to be able to push a script into the server? Especially your
Yeah,
example.
that's also something that we need to consider, not just because of the functionality, but also some of the security issues that we're considering, like because we want to turn on the authentication part, and that is offered by the Level of Things platform. And there's several issues with the cookies and also the tokens, things like that. So we're considering that, and we're having a discussion. Yes.
How easy is it to add new devices and sensors so that you can just call them by name in the interface?
You mean add a new type of sensor or add a new?
Like, I don't know, could you connect to something like a Nest?
Yeah.
Like a Nest,
Sure. Can we switch back to the demo machine, please? Okay.
The voice commands work perfect.
So this is my laptop, and it's the the Level of Things dashboard, and where you can actually add new devices through this portal. And if something that has not been registered will show up here, and you can actually click on one of them and give it actually a friendly name, for example, webcam 2, and choose the location and also choose the applications that actually have access to this device. So in this case, I can choose that, and will show up in all the applications that have access to this. And in the Rules app, which I mentioned, you will see a number of devices that is actually connected to the platform. It doesn't have a very pretty UI, but you get the idea of the functionality parts.
So
is that picking up devices that are being picked up by the Wi-Fi on the computer and/or the Bluetooth?
Yeah, as long as it's connected and it's recognized by
Or
the
directly
Home
hardwired.
OS platform, I think you will see.
For the devices that we already have the drivers for,
Yeah.
like for the like the IP-based camera, it would just that setup flow would just work. And we have a driver for a bunch of Z-Wave devices, so any Z-Wave device would just work. But for Connect, you have to actually write the driver and
Yeah.
get that working. But it's all just .NET code.
Yeah. Okay.
So you're asking more about the Home OS side or what happens with the TouchDevelop side? Because then I guess to actually use this thing on TouchDevelop, you need to extend the library, right?
Right. Eventually we'll have one function corresponds to one function call that is designed for generic apps. So you don't have to write additional APIs. We will make all the APIs that we discussed available as part of the library, so that people can just go ahead and use their menu. It's actually not related to the device type. If you're adding a new type of device, you're still using the Lab of Things model. So you can just.
I mean, the way you refer to those. I mean, when you have one API to send a command to the thing, right?
Right.
And then you put the string there, which says what the command is, right?
Yeah.
Now, I guess it would be probably better to have a separate library for, I don't know, air conditioning, which would have methods to set temperature and things like that.
Right. Set temperature.
Which would be a command, and you can of course send it by just putting the string set temperature there if you know about it.
Right.
But that's not very discoverable.
Set temperature is there are actually two ways of approaching that. One way is because set temperature, if you do have that as part of the operation to the AC, which is a device type, right? If you have that defined in the Lab of Things platform, then the rules app will be able to return that operation for you. You don't have to make any guess, because I do have a basic functionality to tell you that there is an operation called set temperature. And then, yes?
Just a little bit detail. The reason this works is that device functionality itself is abstracted in Home OS. So that gets expressed in terms of roles, which are, think of them as service classes that have operations, which are essentially operations like set temperature. What Zheng does is that basically he takes all those role definitions and he converts them into something that can be called. So if you wrote a Home OS driver or a new role or something, that all of those operations would immediately become visible to his stuff without actually doing anything special, beyond writing just the Home OS role or driver.
Right. It will be shown here as part of the option. For example, the Connect sensor, and I do have the following functionalities available to that particular role, and it's a new one.
So I can just like a class, and you can go to the code and you can see it's basically a class, essentially, that you define with a bunch of operations in it.
Any other question? Well, let's thank Zheng. Thank you.
Thank you.